Welcome to my channel Physics Hub Official. Today we'll explore Rutherford's atomic model, the discovery that revealed the tiny nucleus at the center of the atom and changed how we understand atomic structure. Let's dive in. Before we begin, let's travel back to the early 1900s, when scientists were trying to understand how atoms are structured. J. Thomson had proposed the plum pudding model, but it couldn't explain many experimental results. That's when a British scientist, Ernest Rutherford, came forward with his famous gold foil experiment, and completely changed our idea of the atom. In gold foil experiment, he took a thin sheet of gold foil, only about 100 nanometers thick, and bombarded it with high-energy alpha particles emitted from a radioactive source. Around the foil, he placed a fluorescent zinc sulfide screen to detect the scattered alpha particles. When an alpha particle hit the screen, it produced a tiny flash of light. By studying the pattern of these flashes, Rutherford and his team could see how the alpha particles were deflected. Now see the gold foil experiment apparatus. Source of alpha particles, radium or polonium, in a small capsule. Very thin gold foil, a few atoms thick. Zinc sulfide coated fluorescent screen surrounding the foil, or semicircular detector. Microscope to observe flashes on the screen, or a detector to count deflections. And vacuum chamber, to prevent alpha particles losing energy in air. Now we see the gold foil experiment mechanism. Step 1. Produce the beam. First, alpha particles are produced and allowed through the collimator to form a narrow beam. This ensures the particles strike the foil in a tight, known direction. Step 2. Strike the thin gold foil. The beam strikes an extremely thin gold foil, just a few atoms thick. Most alpha particles sail straight through the foil and continue to the forward detector, label A. Step 3. Detect slight deflections. Some particles are slightly deflected and hit detectors at small angles, detector B. This shows that a small force occasionally pushed them off their original path. Step 4. Detect rare large deflections and backscattering. Crucially, a very small fraction of alpha particles were scattered at large angles. Some even bounced nearly straight back to detector C. This was totally unexpected. The observations of gold foil experiment. First, most of the alpha particles passed straight through the gold foil. This means they did not hit anything inside the atom and moved as if the atom was mostly empty. Second, a few alpha particles were slightly deflected from their path. This shows that they came close to something positively charged inside the atom which pushed them a little. Third, a very small number of alpha particles bounced back or were deflected at large angles. This was a surprising result. It means those particles hit something very hard, dense, and positively charged as the nucleus. From observation, Rutherford proposed his atomic model. First, the nucleus is small, dense, and positively charged, containing most of the atom's mass. Second, electrons revolve around the nucleus in circular paths called orbits. Third, the electrostatic force of attraction between the nucleus and electrons keeps the atom stable, just like planets revolving around the sun. Although Rutherford model was an important step forward, it had some limitations. First, could not explain atomic stability. Means according to Maxwell's theory, revolving charged particles emit radiation and lose energy. Electrons should thus spiral into the nucleus, which doesn't happen. Second, no explanation of electron arrangement, means Rutherford didn't describe how electrons are distributed or how energy levels work. So, Rutherford discovered that the atom has a small, dense, positively charged nucleus at its center. Electrons revolve around the nucleus in circular paths. Most of the atom is empty space. This model is called the nuclear model of the atom. And it explained the gold foil experiment but could not explain the stability of atoms and their spectra. So that's all about Rutherford's atomic model, a major milestone in understanding the atom. If you found this explanation helpful, don't forget to like, share, and subscribe for more science videos. Stay curious, and keep exploring the world of atoms.